Hey guys, how's it going? So, part 6 of this series, I'm going to go ahead and clean up some things that I have kind of made some mistakes on or forgot to do in the previous videos. And then we'll add a couple more functions, and by the end of this video, we will have a working, very basic, obviously, bootloader, which we will add more and more functionality as the videos progress. Okay, so the first thing that I'm going to do is actually fix some things. So in the file that has our interrupts, if you go to your bootloader folder, you go to source, to the core, and then source, and where you have all your interrupt callbacks. Before in the previous video, I simply pasted the callback to the function without even giving it the actual data that we're supposed to pass. What we're supposed to pass is obviously the data that's in the UART. So that's what it's supposed to do. Fast forward the actual UART data. And in this file, we're supposed to include the header file so that it knows that this function, where this function lives. Interestingly enough, I don't even have that function in the header file, so I'll do that too. So let's go here to the top of the interrupt folder. We'll go here and add the include. So now we have that header file, and now we have the function being called properly. Let's go back. Let's go to this header file, which is right here. And in that header file is where the function prototype is going to go. So we're going to take that function prototype, we're going to take it out of the C file. If I can find it. Okay, here it is. And we'll go ahead and add it here. So now it's exposed. Okay, so that takes care of that. The next thing I'm going to do is I'm going to enable the UART RX interrupt. Now, I did enable interrupts in Cube IDE, but that just enables the NVIC line. Obviously, the Cube doesn't know exactly which UART interrupts you want. And the one we want is the RX not empty interrupt. Let me copy that. So I'll just add that right here. And I have this to-do line because obviously once I abstract all this, a lot of this bootloader functionality, because remember the whole point of this bootloader is to be robust but also to be portable. So I don't want any functions that are specific to a microcontroller. So this right here can't live in this file. Anything that has to be very specific like this can't not live in this file. But for now it's fine just for testing purposes. So I've enabled the RX not empty interrupt. Okay. And I already did that where I exposed the UART in the header file. The erase sector function, I need to make a prototype for it. And that is somewhere. Here it is. Let's add that right there. Okay. All right, so now we can start with the new things. So one, I'm going to make a variable for the start address. Remember this, what you see over here is, this is the start address plus the offset to the reset handler. But I want an actual variable to hold my actual start address because I need to be able to increment it. So there it is. I can only make this so big because I do want it big so you guys can see it, but at the same time it's very annoying for me. So yeah. This sector 6, where am I using that? My hex word. I believe that was just for testing purposes. 1, 2. Yeah, just those two. I can delete this now. This is just when I was showing you guys how to write write to the flash. So I'll go ahead and delete that. While I'm at it, all these things are going to go into a new branch. So create new branch, video 6. Okay. Eventually I'll save those into that new branch. Okay, so I have my variable for the start address. Also I need to call my actual boot init function that we made last time. So we can just call that doesn't really matter, but we'll call it after the UART enable thing. Did I make a, yes, I have a prototype for that. Okay. All right, so now we're gonna have a function. Let's do this one first, updating state function. So I'm gonna uncomment this. I did go over how this is going to work, but I'll show you again in just a second. So the other state is going to be the state updating. At the moment, I'm going to skip this state where it's start update state, just so that we can jump directly to updating and so you can see it happening. And from there, we'll go ahead and give this bootloader some thought as exactly what else needs to happen and all of that. And remember, there's a lot of things missing, like there's no CRC checking right now, which is an absolute necessity. But at the moment, we're ignoring that. Okay, so I've uncommented this line, and it's gonna register another function called updating state function, and it's gonna do it at index this, which will correspond with my states. I do have a bootloader current state variable, and it's initialized to idle. Eventually, it will be changed to that inside the idle state function. Anyways, so let me paste this function, and then I'll give you a rundown of how things are gonna happen. Let me go ahead and copy that. Okay, here it is. Let's put it under. Let's put the states in the order that they appear. So idle, and then I'll stick that one there. Let me copy this divider thing. Okay, so let's close that. So here's the updating state function, and what I have going on here is obviously I have a static bool. It's called erased because I'm going to use this to keep track if I've erased the sector or not. So if there's a frame to parse, then it goes in here and it checks if that frame is equal to payload. So if it's a payload ID, then it's going to check that static variable, which will hold its value across function calls, obviously. And if it's already happened once, it will not do it. But on the first run, it will erase the sector, and then this erase equals true is what will block it from happening again. Once it does that, then it go ahead and writes the payload, and then sends an ACK frame. Yes, I will get to this in just a second. We'll implement that function. So it writes the payload. In other words, it writes the new firmware, the 16 bytes to flash, and then it sends a frame, this ACK frame. This tells the PC that it's done with this payload and to send more payload, because obviously the entire firmware is not just 16 bytes, it's thousands of bytes. So it's going to send the next one, and then it's going to keep doing this. It's going to keep doing this until it receives a frame ID whose type is no longer payload, but whose type is update done. Once it does that, then it's going to jump to user application. Obviously, this is very dumb. It's not checking the frames. It's not doing anything. It's just writing them, assuming they're correct. And at the very end, it's just jumping to that. But again, this is just to get the proof of concept going, and we'll add more functionality to this. Okay, so let's write this payload function. Let me go ahead and copy that as well. Actually, before I forget, let's add the prototype for that. We'll put it here under the other one. Okay. So the payload function, it looks like this. I'm going to add that received frame, and let's just add it here, I guess. I don't know. We're going to copy that. Payload function is very simple. It's similar to the other function where all we did was write to flash. So as you can see right here, we're going to unlock the flash. We're going to go ahead and write our 16 bytes. Obviously, this is all hard-coded numbers here, which eventually will be configurable. So we will write the firmware to flash. We'll lock the flash, and then we will reset that received frame that I went over, I believe, in the last video. So once that's done, so we've done that and we've done the update state function. At this point, we should be pretty much good to go to have a full firmware update. Let me change some of the code here so that we can actually get that to work. So I'm gonna just copy, let me just copy this part. Okay. One thing to note, when you do get here to your while loop, to your main, you don't want to do any more printing, especially if you're using the same UART that you're printing with. Because if you start, printing things here, like, printf, timestamp, or whatever you're printing, it's going to go back to the PC app. And it's going to receive that data, and it's not going to know what to do with it. Because the only thing it should be receiving are ACK frames or NAC frames. Remember, this send frame is nothing more than a UART transmit. See, UART send data, which is the exact same thing or similar as the printing function. So don't print anything. Once we start firmware updating, or once you're talking to the bootloader, that's it. You don't want to be printing anything down the same line. If you're using a separate UART for that, that's fine. But in this case, I'm using all through the virtual COM port, so I'm not going to be printing anything. Okay, so here's the function. Dereferencing the function, whichever one is at this variable. And this variable is misspelled because this says LAO, and here it's spelled properly. Let me just fix that right here. There, right there. Okay, time now is capitalized N. Oops. Okay, let me hit save on everything. Let's go to Cube IDE. Hopefully, let me close all of this. Close all. Bootloader source, bootloader.c. Let's make sure everything is saved. Let me go back to VS Code. Make sure everything is saved here. Save all. Okay. Just want to build, make sure there's no errors. Usually there are. I have 3 errors right now. Let's see what they are. Error. Where are my errors? Warning. Okay, error. Static declaration. Okay, I didn't write the prototype for that. So let's go ahead and write the prototype for that. And let's just stick it. I hate scrolling in this thing. I'll just stick it under the erase sector. That's the only error I see. Maybe that will take away all 3 errors. Okay, so the errors are gone. Let's go back to VS Code here. Okay, so basically what I'm going to do here is I'm calling whatever function I'm currently in, which will depend on what state I'm in. I'm gonna wait 5 seconds, and if 5 seconds have passed and I'm still in the idle state, then I'm gonna just jump to the user application. Again, this is very dumb. I'm not checking if there's an application that exists or not, and if it doesn't, then it will just crash because there's nothing there. But for the time being, that's okay. I don't mind. I'm gonna give myself some more time. Let's do 15 seconds. So 15 seconds, and then I will go ahead and let me build this again. Okay, now I'm gonna go to the this is Visual Studio IDE, and this is now, by the time you're watching this video, you can go ahead and go to my GitHub. I'll post a link of this repo, and then you can go ahead and use this and flash your own firmware. Now, there's some things you need to change. First of all, this is community, I believe, 19 or 2022. So this is 2022. These are all the stuff that I have installed on it. I think you only really need to install, I'm not sure, C#, Visual C++, desktop tools, WinForms. At the end of the video, I'll post everything that I have enabled and installed on this Visual Studio IDE distribution, so that when you install it, you can install the same ones. And it's big, guys, so that will take a while. In fact, maybe you should fast forward to the end of this video, look for the part where I show you what you need to install, make that go do its installation, come back and watch this, so you can kill some time. Okay, so once you do have you've cloned this and you have this project, the only thing you need to really do is go into your device manager and see what port your ST-Link is on. So mine is on port 3, COM3 right here. And then that is what you're gonna put right here on port name, COM3. I haven't made it configurable yet. It's just kind of hard coded. I'm just opening the port and everything. Okay, so then you're gonna press start on this, and once this loads up, what you're gonna do is you're gonna open a binary file that you want to load. So for example, here I'm gonna load this user app. You're gonna click connect. It may generate an error if you don't have the right port, or it'll tell you something, but you can always read the errors down here. So mine is telling me, well, nothing really. If I try to connect again, it'll tell me that it's already open. And that's good because that means I'm already connected. So I'm connected and I have loaded the binary file. Don't press flash, not yet. I'm going to go to cube and put this to the side. And I'm going to go ahead and run this. And once I start running, I should have 15 seconds to start the flash. So before I do that, let me erase the chip. Just to okay, so I've erased the chip. I don't, you know what, let me verify that this is still connected, because I don't know if connecting to that app makes it. Okay, yeah, it's still connected. I wasn't sure if that ST-Link used the COM port and kind of kicked off my other app. Okay, so I'm gonna go ahead and run this. Run. I'm gonna bring this window back. I'm gonna wait for that to do its thing, and if it works, it works. If it doesn't, then we'll start debugging and see what's going on there. Okay, so it's running supposedly, and I've hit flash and nothing happened. Okay, let me restart. Let's restart some things, because sometimes this may or may not work. As you can see, because I've been running this a lot. So that's working. I have 15 seconds. Hopefully I'm not going to run out of time. User app, connect, flash. Oh, there it is. It worked. Okay. And it's going to say done eventually. Now it's done. And I know you guys can't see it, but it is blinking the LED, which is what that app does. And the reason I had to restart it, I'm not exactly sure what it is, but it has to do with the COM port, I guess, because after a couple of restarts and all that stuff, it just, I don't know if maybe there's old data in the COM port, and that has to do with this app. Maybe I'm not flushing something. There's some leftover data there. I don't know. So yeah, this is definitely a work in progress. So be patient with that. If you need to redo something, you can't just, press flash again. Like once I've done this, and that's so, it doesn't even show everything. Let me make that bigger. Let's make that a little bigger, because I know it's like 8,000 bytes. Okay. So let me, because I want to show the app working. So at the moment, let's connect to the serial monitor on Cube. Where's my and see what's running there right now, because it jumped to user application. So right now it's blinking an LED, and it's on COM3. And okay, so it's not really printing anything right now. Okay, so let's see. I have, because what I'm using there is a user app, but it's from a different application. It's from my personal copy of this. So let's go to this user application. Let's see what this one does. Actually, user app is right here, app.c. This one says user app, and it's printing once every second. So let's make that 100 on, maybe not that much, but like 300. So every 300 milliseconds, it's gonna print user app. blah blah blah. Let's change that. Let's put YouTube tutorial. Oops. Okay, so it's gonna print that. I'm gonna build it, but I'm not gonna flash it. So it's built. I'm gonna go to this this app. I'm gonna find that. So let's do that. So you see that's Eclipse Workspace. So that's not the same user application that I have, because that one is in my YouTube workspace. So YouTube tutorial, user application, and this is that one we just did. Where's the binary? Right here. Okay, so that's the binary. I'm going to connect. I'm going to restart the microcontroller. I'm going to hit flash, and again it doesn't do it. I have to plug and unplug the actual. Let me get because I don't want to run out of time. So I'm going to just preload this. Here's the binary. I'm going to turn on the Nucleo. I'm going to connect, and I'm going to hit flash. Okay. It's flashing. Ooh, this one's bigger, 10,000. And it's done. Now, since this is on COM3, I can't have this and this at the same time, because I want to show the print statements. So I'm going to close this and go here and go to the terminal. Go to COM3, close that. Failed to open COM3 with selected settings, blah, 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 blah. Why? It's, this thing still, okay, actually, I didn't end the application. Yeah, this is so annoying. So when I close that app, it doesn't really terminate anything. Obviously, this is buggy because I'm not a C# developer, so who knows what I'm doing there that's wrong. Okay, so now I should be able to open COM3 here. And holy shit, yeah, there it is. It's printing that stuff every 300 milliseconds. So there it is, guys. That's a working bootloader, essentially. Very basic and crude. Okay, so that's the end of basically the tutorial. Now you can stick around and watch what I'm about to do, because what I'm going to do right now is kind of go back and forth between the computer side and the firmware side and show you how things are working. So that's going to make this video be a little longer. Actually, you know what? No, it's already 22 minutes. I'm not going to do that. I'll make a separate video for that, which can be an optional video. So thanks, guys. Any questions, please do join the Discord channel that I have for this. And just let me know. Also, if you are interested in helping me develop like a Python application for this, which is what I would prefer instead of this C# thing, let me know. And if you do want to help me do that, you should probably watch the next video where I go over how this works and how we're communicating with the firmware. That way you know what it is that you need to do out of Python. I will give it a shot myself working with Python, so I'll see if I could get far with that. All right, guys, thanks.